All right, thanks for joining us. Again, this is CJ Sloan, the CTO at Sloan Lubrication. And I have with me Steve Spots, Matt McCarthy from our sales group, as well as Mike Bechtold and Brian Sloan. Mike is our COO, Brian Sloan is our CEO. So I'm going to be doing the majority of the front part of this presentation, but as we get to the Q&A part, they may chime in. So yeah, I appreciate you all joining us today. The purpose of today's session is to talk about the TriCip lubrication solution that we have. We're going to do a brief presentation, a little bit of a demo, along with a Q&A session, and hope to answer any questions you guys may have. So first of all, as an introduction, this question comes up pretty frequently. I thought I would start off with a little explanation as to what TriCip is. So the name TriCip comes from the roots tribology and reciprocating. We kind of combine that together, and essentially TriCip stands for the study of friction and wear in reciprocating machines. So the TriCip product line is designed specifically for lubrication of reciprocating compressors. Right now we have a fluid and a delivery system that we'd like to talk about today. So just so we're all clear, the prime purpose of our TriCip solution, we're talking about the cylinder and packing lubrication system, not the frame system. So our TriCip system delivers precise amounts of a very specifically designed fluid only to the rod packing and cylinders. Through some things we'll talk about here, we're able to deliver much smaller amounts of fluid to do the job of lubricating the cylinders and packing than we have before. Our system allows guaranteed delivery of this fluid, provides much more operational visibility and intelligence to the operators so they know what's going on in the system, and is a whole new end-to-end supply chain for these fluids. So this enables you to have fluids being delivered to your compressor, day tanks, deliveries using common carrier, and we minimize the waste disposal of fluid downstream from compressors, and we're reducing the site liability related to the storage of oil at a given site that has operating compressors. So the system as it stands now is made up of two key components. We have a new fluid that's specifically designed for the compression of gas, specifically natural gas. This fluid enables much lower delivery rates, lubrication rates, sometimes you call it. There are different terminologies for what lubrication rates are, but basically we're delivering fluid to replenish the lubricating film inside a compressor cylinder. Along with this new fluid, we've developed a new delivery system that is specifically designed to deliver this new fluid. We also have introduced closed loop computer control. We're using some DC gear motors, which will show you that where we can automatically adjust the delivery rate. We can have automated break-in, adjust the rates over different periods of time depending on different conditions without having to have an operator come and necessarily make adjustments on pumps, keep track of cycle times and things like that. We have a new friendly user interface through a small touchscreen on the system. The system is cloud connected and reports through a cellular connection when obviously there is cellular signal available and our customer allows it. And the whole system is a low power DC supply. If we're getting DC directly from our customer from say a UPS system or something like that, the entire system requires under 2 amps during normal operating condition. That includes the motor. So it's really easy and very reasonable to integrate it into existing control systems. And we'll talk a little bit more about that in a few minutes. All of the components are located, or all the main components are located inside our cabinet, which is designed for easy and quick maintenance. And that really prevents people from having to climb around on the skid as much When it comes time to do maintenance, it's removed from the compressor skid or sitting in a corner of it or next to it. We have some photos we can show you. So, and all of our components, I mean, this is Sloan in general. We do reciprocating compressor lubrication. We manufacture all of our own components in-house, all the critical components. And all we do is lubrication of compressors. So all of our products are pumps and divider blocks and check valves, and the components of the TriCip system are designed specifically for lubricating reciprocating compressors. So the fluid itself is called TriCip GC68. GC stands for gas compression. This fluid is only for use in compressor cylinders. It is not designed or formulated for use in the crankcase, in engines, etc. But because we didn't make it a general purpose fluid, it does the job of lubricating a reciprocating compressor very, very well and with very tiny amounts. It's an ISO 68, so it's nice and lightweight. We don't have a lot of trouble in cold weather, for example, and having to heat trace lines. It flows very nicely, and it separates out from the gas very nicely as well downstream. The fluid itself is delivered in 20-liter bib containers. BEB stands for bag and box. The 20 liters is about 5.3 gallons. It's a nice man-portable size. And it's very similar to a large, box of wine, for example. They're portable, they're shippable directly in common carrier, and they get loaded directly into the system and are fully recyclable when they're empty. So the delivery system is a fully packaged lube system. Again, has the closed control of rates, automatically adjusts motor speed. We have redundant pumps on board so that if the system detects that one of the pumps is starting to degrade a little bit, or maybe a check valve has clogged, or there's some sort of a supply issue, the system automatically and online will adjust the speed of those pumps and take over. And the idea is that we want to make sure that we're guaranteeing delivery of the fluid to this compressor at all times, even when there might be a warning or a condition where performance might be degraded. We want to overcome that, alert operators, and have planned predicted maintenance rather than having emergency shutdowns. Oh, all of a sudden it got too cold to deliver the fluid, or something like that, for example. All of the key critical components internally are designed and manufactured by Sloan in-house here in Western Pennsylvania. All of the sheet metal, I mean, everything in this system really comes from probably a 200 to 300 mile radius around Pittsburgh. We're really great local American-made supply chain, and we're very proud of that. We've also developed a polymer tube strap system that we use to install these. So any tubing that gets installed out on the compressor frame itself has no metal-to-metal contact. So there's a lessened chance of a tube cutting into a casting or a tube cutting into another tube when there's vibration. And as we know, hey, there are reciprocating compressors. There is going to be vibration. There's no way around that. So we do what we can to try to minimize that as much as we possibly can. So the new standard of system, which we consider to be our TriCip system, this is what it looks like installed at a customer's location. This is a 6-throw aerial KBZ6 3-stage gas gathering machine with a Caterpillar 3616. This is here in the Marcellus Shale. So this is what a typical installation might look like. The cabinet doesn't always necessarily look quite as pretty and where it's located as this does. It depends on the site and what they have available, but this is definitely a nice installation here. Here's some other examples of installations that we've done on some various machines. The one in the top right, those are two Cooper GMV 6-3s, I believe. The middle picture is another, I think that's a JGC6. I'm not entirely sure, but you can see the TriCip system is installed directly next to the control, and there's some conduit running up over the top that is bringing the power and signal back and forth between the system and the unit control panel. And here are some pictures of what our polymer tube clip system looks like when it's installed. And you can see how nice and clean this system looks when it gets installed and how it reduces vibration.
CJ, can I chime in?
Absolutely.
We got a question from Pablo, and I'm not sure if you can see it on your screen, but you may want to answer it now or maybe at a more appropriate time. But he asks, how does the presence of H2S or CO2 in the gas affect the amount of fluid? I assume the lubrication fluid.
Okay, yeah, sure, that's no problem. So the presence of H2S and CO2 should not really be affecting the viscosity of our fluid. There's a special, extremely inert additive that we have in here that is highly resistant to dilution from the hydrocarbon or the dilution effect that we would see in H2S and CO2. That being said, we have not tested it in very, very highly sour gas applications yet. We're really interested in finding a partner who's interested in doing that. So, you know, if that's something that we're interested in trialing and testing, we'd be happy to do so. But we have very high confidence in the testing that we have done that we're going to see extremely good results in the sour gas applications.
All right. So Pablo, just I'm not sure if you can see it, CJ.
No, let me
chat.
Let me see if I can pull the chat
up.
he
just mentioned the lubrication fluid. So I think you addressed it.
Okay, great.
He says thanks.
No problem. No problem. Happy to answer any questions that come up as we go. So, and I know I tend to just keep going, so feel free to interrupt at any point. So when we talk about lubrication rates, I'm just going to touch on this briefly. I presented a paper at the GMRC in 2018 where we talk in much more depth about lubrication rates and how we calculate rates for this fluid. If you can't find that through your GMC materials from past conferences, let me know. Be happy to provide that and talk about that individually with you. But, you know, typically what we see in OEM rates, and this is any manufacturer, either a legacy manufacturer like, Cooper or Clark with slow speed integrals, or more recent manufacturers who make high speed machines. Typically, we see all OEM rates fall above 3 million square feet per pint. So if you imagine if you take 1 pint of oil and spread it out over a surface area, you are going to see rates above that. So that pint would be spread over 3 million square feet or less surface area. And that surface is swept surface area within that compressor as the rings in the piston are sliding back and forth within the cylinder. There are some high-speed OEMs, depending on the conditions and what the machine was designed for, can be as high as 650,000 square feet per pint. And the general industry perception has always been that higher rates are safer, but with our experience, there's a lot of additional cost associated with delivering more oil to these compressors. We have the additional cost of the fluid itself. We have mechanical issues within the compressor, valve stiction, residue buildup from additives within these oils building up, causing broken valves, excess fluid, excess packing wear due to hydrolocking if there's really way too much fluid in the packing, which then can lead to premature replacement or gas leakage. Then we have the whole problem of removing this oil from the gas stream once it's been introduced. So as we know, lubricating a reciprocating compressor, this is every drop we put in there gets carried away by the gas stream and has to be removed someplace else down the line. And that's a really hard thing to quantify dollar-wise, but it adds up really fast downstream. Think of the cost of pigging, the cost of valve or meter contamination, the efficiency of the pipeline, contaminating storage fields, things like that. Anything we've seen so far? Okay, so let's talk about some of the benefits. So, obviously oil consumption is a huge one. We can achieve over 90% reduction from OEM rates. Obviously, this is a little bit of a moving target depending on the application. Pablo obviously brought up H2S and CO2. We may very well not be able to achieve 90% in that situation, but we can see very drastic reductions. Did a very controlled 18-month study on a gathering unit that was having valve problems. We showed 75% reduction in valve replacements on that unit after a 12-month runtime with TriCip. That's a lot. That's a lot of downtime to replace those valves as well. We have reduced site liability and improved reliability with our proven components that we've been manufacturing for many decades. We also have the added redundancy of 2 pumps running at all times, so the system can automatically take over. We also have the improved operator visibility. I mean, I'm sure that we're all aware of how difficult sometimes it can be to identify what the given delivery rate is for a given machine, and then what should that delivery rate be. Just because you have 10 machines in a row doesn't mean that every one of those machines should have exactly the same rate. They may be slightly different models. They may have slightly different cylinder sizes. And that's often a moving target, especially when a lot of operators identify their lube rates in cycle time, in seconds. That's very difficult when you may have blocks on different machines that are different sizes. Just because your cycle time is 15 seconds on one machine doesn't mean it should be 15 seconds on the other, even if the flow rate should be the same. We're also addressing some safety concerns. The auxiliary end of a machine can be a very complex thing. There's piping running everywhere. We have oil lines, cooling lines, crankcase lines, gas piping, pneumatic lines for loaders and unloaders, and I mean, you name it. And all that stuff invariably tends to have a slick of oil all over it, and it's not a very safe place to be working. So by removing that from the skid and making an auxiliary system, we can improve the safety. We also have available a suite of communications that we can help enable this visibility to operators and management. We have a web portal. The system and the web portal can send email alerts whenever certain conditions are met. If a tank goes empty, we can alert the operators so that they know, hey, next time you're out in the compressor building, we have to change the tank. And then we have digital communications with the unit PLC or your station SCADA system. So we give you all sorts of visibility into things like what are our tank levels, what are our discharge pressures, what's our motor speed, things like that could be tied into a historian system or an analytics system like Pi to enable long-term visibility into trends. So as an example, we picked a customer's machine we have running currently. It's 1,000 RPM, 6.5-inch stroke, single stage machine. Before we installed the TriCip system, it was running at 53.8 pints a day for a fairly significant oil cost of a little bit under $20,000 a year. And we're running at 1.8 pints per day today. So that's 75 gallons a year. That's a 96% reduction in fluid consumption on this machine. And our customers are very happy. And we've had some of these systems installed for quite a long time. Some of them have only been for a year or two. So we're still working with some of them to quantify what their long-term downstream effects are really going to be. So again, we talk about some of our effects, process contamination, discharge filter life, improved reliability, and where we stand today is we have 96 of these units currently in operation. The longest has been running for 45,000 hours. It has had essentially no maintenance in that time. We have changed a high pressure filter, and that's it in that period of time. We have units running in gas gathering, storage, and transmission services, and a mix of low speed, integral, separable, high speed, pretty much whatever you could be looking for. So we're about 20 minutes into this. Anybody have any questions at this point or anything we'd like to address? Okay. Well, what I'm going to do next, and I'm going to turn on, I'm working on my phone here. So I'm going to quickly turn on my phone camera and stop sharing. And this worked in their test, so let's hope this works again. And I'm going to show you our demo TriCip system that we have running here. Now, a caveat, this system obviously has its covers taken off, and this is in our conference room. We don't happen to have a compressor here in our conference room. So it's not actually hooked up to a compressor, but we have it set up so it's recirculating. So it's sending its own oil back to itself. It allows it to function as a demo, but it doesn't really give you the full true field experience that you might expect. So a quick overview, we have our HMI, our display here. And this is a cabinet. I know I'm about 6 feet tall. I'm holding this at eye height. So, you can see what the cabinet looks like. We have our control panel on the side, which we'll talk about here in a minute. Our pumps are down below. This is a dual zone unit, which means it's configured to deliver to an integral machine, both for the compressor cylinders and the power cylinders. We can't deliver TriCip fluid to power cylinders, so we're using the crankcase fluid to deliver the power cylinders. But this motor drive in the front is set up to deliver to the compressor cylinders. And in the middle here, we have our door, which is where our operator is going to interface most frequently with our oil tanks. And you see there are two of them here. And this tank is not, this demo is not set up with our bag and box system. We didn't actually have time to convert it over, but I do have one of our boxes. This is one of the box systems, or the box tanks. So there's a collapsible bag inside here, and this gets open just like a box of wine. You would push in this cardboard and pull out a nozzle, and that would get connected to a quick connect right here. So the system has two tanks. It's draining these tanks in series. So at any given time, it's only pulling oil out of one of them, and the other one is in standby or it's empty, and the system is notifying the operator that it will need to be replaced. And the time for one of these tanks to drain is anywhere from 1 week to, on smaller, slow-speed machines, we've seen just under 50 days for the lifetime of one of these tanks of continuous operation. So that's been one of the concerns that we had initially with some of our operators. Was, hey, I'm going to have to go on the compressor building and change these things like all the time. It's going to be constant. But it's been our customers' experience that they actually have to spend less time with this system changing tanks and swapping things out than they would for their normal system, having to refill overhead day tanks from external tanks with air-driven diaphragm pumps or however it was set up. So we have our interface here. Oh, and up top we have an indicator light. So that indicator light provides the status of the system at any given time. If you have several of these in your facility, they pretty much sit in the corner and do their job as necessary. And the indicator light is kind of used as an at a glance. You can look down the row of your machines and see if one of them needs some attention. Maybe the delivery discharge pressure is a little high and you need to see what's going on, or maybe one of the tanks is low and it needs to be changed out. And on the right-hand side, this is our electrical panel again. Our standard system is built using all Red Lion controls, but we also have an option to build systems with Allen Bradley or the PLC provider of your choice if you have a hardware preference. But that's something that we can always address. So our main menu here shows the status of our two tanks, tank 1, tank 2. That corresponds with the left and right-hand tanks in the system itself. And in this unit, we can see we have two zones. They're labeled compressor and power. Zone 1 is obviously compressor cylinders and packing. We have it set up for 4.2 pints. In this case, this is our power zone set up for 42 pints. This unit's not running right now. Obviously, it's not hooked up to a real compressor, But, I'm in local control mode, which I can start and stop the machine from the control panel here. That's useful for maintenance whenever, you're doing work inside the building or, purging a system out after you've done maintenance to it. So if I hit start, you can hear the pump start up, and you'll notice our indicator light up top goes green, indicating that everything is good to go. And our pumps down below have started running, and they're running an auto sequence at the beginning that we call flushing. So this is kind of like a pre-lube cycle. We run the pump at maximum speed to make sure that we've pulled oil in, we've started to draw suction from our supply, and we're pressurizing our system downstream. When we start up, we don't necessarily know how long it's been since that compressor ran last. So we always assume that we want to pressurize the downstream lines, get the divider blocks moving as fast as possible. And once we've confirmed that we have a number of positive cycles of the divider block, then those motor speeds will automatically ramp down to our designated speed. So you can hear it's already gotten a little quieter as those start to slow down. And the system will slowly ramp its way down to our desired rate, and then sit there and maintain that delivery rate, until the compressor stops or there's a problem. And it, in our experience, that is typically a very long time. So happy to address any questions anybody might have, or Steve, if anybody's text or has any questions on text, anybody would like to see anything in particular, I'd be happy to do that.
I haven't seen any more questions come in, CJ.
Okay. Okay, so maybe I can take a second and how are we doing on time?
I've got 2 minutes.
2 minutes, okay. So, we can quickly walk through some of our menus. Here's our main menu where we can choose all of the different sub-menu options we want to look at. Main takes us back to the main screen. The zones menu is for setting up all the different zone options. So this lets us switch our control from auto speed to manual speed if we wanted to run manually at a particular motor speed for some reason. It gives us some statistics here as well. And then we have our flow setup. This is where we set the displacement and the alarms for our first zone. Gives us some more statistics here. Also lets us name the zone and choose whether we want to see average or instantaneous. We also have some advanced options in here. This is where we would set our auto break-in period. So if we're going to do maintenance on a machine and we want it to break in for, say, 200 hours, you would set that here and turn it on, and it would automatically run a break-in cycle. We can also enable flushing. There's some applications where people may have, a higher level of waxes or something that may build up inside their compressor or their piping, and they want to run an occasional flush. That flush runs the motor at full speed for a set period of time at a particular duration. So that would, that enables that, and that would just run that flushing cycle automatically, which could, flush debris off of valves if you have accumulation inside the machine or in piping. And the same options are available for the second zone. We also have our tank setup. This is where we would switch from tank, or if we want to manually change a tank, that's done here. We also have the ability to pull oil from an external header, and there's a setup page in here for that. That's not enabled on this unit. And we have system. This is where we can see some kind of more statistics on what's going on within the system. Information about the unit, where it is, how many run hours it has, the software versions, things like that. We have built-in maintenance counters where we can see, runtime for different maintenance events and things like that. And these are all user configured. We have trends where we can see the trend line of our flow rates for zone 1, zone 2. We can see our tank level and discharge pressure trends as well in there. All the things you would expect from a kind of a standard PLC. So that's pretty much the basics of our system. And I really appreciate anybody who's been attending and watching this, and I'm happy to answer any other questions that might come up, or I think we're out of time, so we can cut it off there. So I'm going to switch back from my camera unless anybody wants to see more. And see if anybody has any questions.
All right, I'm not seeing any questions come in, but for those participants here, if there's any follow-up questions you have afterwards, you can reach out to us at sales@sbco.com. That's Sam, Bob, Charles, Oscar, sales@sbco.com, and we'd be happy to follow up and talk more specifically about your application if there's interest.
Well, it looks like we do have somebody. I managed to pull up the chat here, Steve.
Okay, I wasn't seeing that.
We have somebody typing a question here. Okay. Yep. Thank you very much for attending as well. And I appreciate everything. And I believe this a recording of this will also be available on our website and on our GMC booth, maybe later today or tomorrow. All right. Thank you all.